Welcome to a lesson about proportions in triangles. If you've been with me the whole time, we've gone and learned about proportions, what they are and how they work, what similarity is, what it means to be similar in polygons, how to prove triangles congruent using the three methods we discussed in 7.3. Last section, we talked about another concept called the geometric mean and how it's calculated. And lastly, we're going to talk a little more about some more proportions in triangles. And the idea of what a proportion is isn't going to change, nor is the way you solve them. It's just the ideas of, well, this is how it's created. So here's the first one. Creation of these comes from the side splitter theorem, which tells us parallel to one side of a triangle, you got a line, parallel to one side of a triangle, and it intersects the other two sides. That divides it into proportional pieces. You see in example 1, SU goes across and cuts that up and makes it parallel with the bottom. You're going to be able to write a proportion. And, excuse me, that would look like what you have here. Now they use a method of multiplying both sides by 16 and getting the answer. Continue to use cross multiplying. So you have side splitter theorem. Just another way to get a proportion in a triangle. Then you have a corollary which says when you have three lines and some transversals, this proportions can happen. You see down in example 2 with the sail, that can happen. All these are parallel at the bottom, and you can create your proportions from that to solve. And then the last one's a triangle angle bisector theorem, which says if you have an angle bisector, it's going to cut the opposite side into proportional pieces, and there you have that. And that translates over into your study guide. We worked on, for the geometric mean, up to 56, so you need to do 57 to 80. And I've gone ahead and set some of them up, so let me talk you through it. Number 57, to solve for the missing piece, I called it X. I wrote over top instead of the question mark. What you need to do is you need to look at and figure out how to compare two triangles. The first one is the one I just highlighted in red, and the second one's going to be this great big green one here. But those are related by what I wrote out here how it follows. The red triangle's side of 2 is related to, if you go to the big triangle, that'd be 6. 2 plus 4 gives you 6. The other side of the triangle in the little one is X, and it's related to 12. So same shape again, corresponding sides, sets it up like that. The common mistake people have in something like number 60 is they look at this place right here that's actually a quadrilateral. It's a four-sided shape. They try to use that, but really you don't need it at all. You can't use it at all. You're going to relate this little triangle right here to the whole one, the big one. Its bottom is 8, corresponding side's 10. This whole thing is 15, which is where that number came from. And if you just say 15 minus x, you'll get that side, which you have there. Set it up, cross multiply, and do your algebra to solve. And you have pretty much the same thing throughout the rest of these. If you have any questions, please be sure to ask. And for those of you that are faithfully watching, what I'm going to do now is I'm going to show you some answers. So here's your answers for page 1. Moving to page 2. Go on to page 3. Comes page 4. Now on page 4, good thing to note is how it always says similar, side angle, side similarity, and then this thing right here would go in the blank. Triangle EFG would go up there. That's what I'm going to be looking for when you do your test. Oops, sorry, I went too fast. There's 31, 32. Go down here, the bottom 2 on this page. Pause me and keep playing later if I'm going too fast. Page 5. If you've not noticed, the answers are in red, these numbers down here. Page 6. There you go, like that. On page 7, And page 8. Page 9. Finally, the last page. And there you have it. Please ask questions and get them to me if you have any. Otherwise, thanks for watching, and I'll catch you on the next video.